So today we are going to start lecture 25, and essentially in this lecture we are going to discuss the topic of automatic differentiation, which I will generally call as AD, and I am Dr. Ranjan Ganguly. Now this method, which is known as AD, is a process of differentiation of the statements in computer programs to calculate derivatives. So this is something which is very different from the previous method we have discussed, which was finite difference analysis or finite difference formulas. Here what you do is that you typically use the fact that most objective functions f of x are calculated using some computer program, and so are the constraints. Now, if you could create a new program which would differentiate these particular objective functions and constraints, and this could be done using some computerized method, then you would save an enormous amount of time. And the important part about this particular method known as AD is that it's useful in getting high quality gradients. So that's something which is very important. Now, we have seen that finite difference derivatives are very powerful, and there are most problems where finite difference derivatives have to be calculated. But we saw that the problem with finite differencing is about the calculation of the step size. The step size plays a very important role in the correctness and veracity of the finite difference derivatives. And for a typical test function for which you know the answer, or for a function for which you can calculate the actual derivative symbolically, you can very easily check your derivatives value and compare it with what you have got with the finite difference derivatives. But when you are dealing with computer programs, this is not possible, and therefore you have to take whatever value the finite difference derivatives are giving you and work with that. And if these values are not good, then your optimizer is not going to work very well. So again, what the AD software does is it takes a program which typically calculates the value of this function f of x and creates one more program which calculates the value of the function f of x and its gradient c. So essentially, two things which you are interested in any optimization problem are the value of the function f of x and the gradient vector c, and essentially this particular software is going to give you these values. Now, how these softwares work is primarily through the use of chain rule differentiation, which is a very important part of calculus. So essentially this is using a very simple theory in calculus, and what you do is that you express any function calculation process as a sequence of simpler calculations which involve at most two variables. So essentially when you are writing a computer code for a particular problem, you finally have to express the function in terms of certain design variables. And these design variables are going to have certain facts or operations which are connecting them. For example, plus, minus, multiplication, division, square root, exponential sign, and so on. So you need to create some intermediate variables which essentially express this complex function in terms of a large number of intermediate variables, where each of the simpler calculation involve at most two variables. For example, any such calculations are permitted. For example, x1 plus x2, x1 into x2, x1 square, sine of x1, e of x1, and so on. So if you have a more complicated function, let us say all these are summed together, then you may define x1 plus x2 is equal to x3, x1 x2 is equal to x4, x1 square equals x5, sin x1 equals x6, e to the power x1 equals x7, and then you have a large number of variables, and then the AD software essentially works on these variables. Now, while the process of AD is quite complicated and there are theses written on this and a lot of publications which you can find in Google Scholar, the advantage of this method is that you do not need to write the code to perform the AD problem. That is in the case you are not a PhD student who is actually doing research on this problem, but you are somebody who just wants to use these particular software to calculate derivatives. Because you have freely downloadable AD software which is there on the web. So one such software with which I am familiar with and we have used in some research is known as Tapenade, Tapenade, and this is developed by INRIA in France. Now, essentially, when we use Tapenade, it worked with Fortran programs, though there are extensions of different languages which are also possible in the future. So you can freely download this particular software and use it. And what this software will do is that it will take your computer program and it will create a computer program which will give you the derivatives. So just to see how this would work is that if this software works on a piece of code or a line of code given by x1 is equal to x2 into t10 plus x3. So here x1, x2, x3 are design variables which are scalars and t is a vector which is of size 10, and this again could be a function of the design variables. So what the AD software does is that it differentiates this program, and so the differentiated program would have something like this: dx1 equals dx2 into t10 plus x2 into dt10 plus dx3. So essentially simple chain rule differentiation has been used here, considering this is u and v. So you have got u into dv plus v into du here. And by doing this kind of differentiation inside the program or in a program, it essentially creates a program which gives you very good derivatives in terms of quality, because you are seeing no approximation is made here. It is simply chain rule differentiation rule which is being used from calculus. So again, as far as this particular method is concerned, this is a method which you can use if you have access to a program. Now this method will not be useful if your program is some kind of black box or a proprietary software. But if you have developed a particular program as part of your research or part of your development work in a company or in a university setting, then essentially you can download this kind of AD software and then you can subject this software to your computer program and then let it do the derivative calculation. So essentially this is a very good way to develop good estimates, and very often this is used in gradient based optimization. So in many large scale gradient based optimization problems where finite difference derivatives may be expensive to calculate, you could use an AD software to facilitate your research and development work, and it would help you get some better result. Now, this software Tapenade as well as supporting information and tutorial can be found in this particular web page, which is at the time I am making this video. And sometimes these web links change, so just Google search for Tapenade and that will bring you to the particular web page which is currently there for this problem. And you can practice this with some simple functions. Maybe you can write a simple functional code and check out how this Tapenade is performing, and then once you are satisfied with this simple code which could use some test functions, you can subject this to your actual code which is coming from some kind of solution of partial derivatives or more complicated equations involving partial differential equations and so on. So again, this was a slight detour into one more aspect of differentiation, which is coming from research but is also of great practical value, and you can explore this particular tool and see if it works out for you. So again, this ends lecture 25, and in the next video we are going to discuss one more approach, and that is essentially how to calculate sensitivity derivatives. So there you do not use some software, but you actually try to use your domain knowledge of the subject and create code inside your code such that the code not only calculates your function f of x but also calculates the gradient vector. So this particular process known as sensitivity derivatives are very useful in problems where you are a domain expert, you know your computer program very well, and you are going to apply this particular computer program to a particular optimization problem, and you can also get very high quality derivatives in this process. So I'll see you in my next video.